Dear students, we are handling Senior Mathematics 2A complex number objective in the topic of complex numbers objective. Level 3 is going on. Complex numbers objective level 3. Level 3. Yesterday we have discussed 10 problems. Today let us start from 11th question. 11th question. If P is a point satisfying argument that is equal to pi by 4. P is a point satisfying argument that is equal to pi by 4. Such that the sum of its distance from two given points 0, 1 and 0, 2 is minimum. Then P must be k by 3 into 1 plus I. The numerical value of k should be. Condition we can write Pk plus Pb is equal to minimum. So sum of distance from the point P to the given points 0, 1 and 0, 2. Here this is 0, 0. This is 0, 1, the point on y-axis. This is 0, 2, the point on y-axis. This is y, this is x. Argument given as pi by 4. So it is nothing but the point should lie on the line y is equal to x. Because the argument is pi by 4, like this you can write passing through origin, the equation of line is y is equal to mx. Here m is equal to tan 45 into x, it is 1 into x, y is equal to x. Now, reflection of this one is let the point is here P. What he is discussing with us, one vertex P is a point satisfying argument equal to pi by 4. That meaning is the point P lie on the line y is equal to x. Just wait a second. Now we can calculate reflection of 0, 1. Reflection of 0, 1 with respect to y equal to x is 1, 0 because y becomes x and x becomes y. And in the similar way, reflection of 0, 2. Reflection of 0, 2 with respect to, here I mean x meaning y is with respect to the line y is equal to x here. That is 2, 0. Put here 2, 0. So you should join like this or like this, anything. Maybe the point P is the locus. Here, maybe this is P. Here also you can take the variable point P. Now draw like this. This is A, this is B, this is C, this is D. Now equation of, not like this. Equation of CB. Equation of CB or equation of AD. Equation of CB or equation of AD you should calculate. Whenever we are joining like this 1, 0 and 0, 1, it becomes equation of straight line in intercept form x by a plus y by b is equal to 1. So it is x by 1 plus y by 1 is equal to 1, x plus y is equal to 1. So from that equation, if x plus y is equal to 1 is there, if x plus y is equal to 1 is there, if the x plus y is equal to 1 line substitute intersecting the line y is equal to x, if substitute here y is equal to x, put here x plus x is equal to 1. So it is becoming 2x is equal to 1, so x is equal to 1 by 2. So whenever x is equal to 1 by 2, y is equal to also 1 by 2. He is given the question that k by 3 into 1 plus I. So 1 by 2 you should not get. That is why I did not join according to our option. 1, 0, 0, 1 I did not join. In the similar way 2, 0, 0, 2 also should not join. Because if you join like this 2, 0 and 0, 2, x by 2 plus y by 2 is equal to 1, x plus y is equal to 2. If you substitute that whenever the line is intersecting the line y is equal to x, the intersecting points you will get. So if you substitute the intersecting point y is equal to x there, if you are getting x plus y is equal to 2, put here x plus x is equal to 2. So 2x is equal to 2, so x is equal to 1. And y is equal to also 1. 1 comma 1. There is no question of 1 comma 1 in the given question k by 3 into 1 plus. So it is wrong. So that is why you do not consider 1 0 0 1. So you should consider 1 0 to 0 2 or 2 0 to 0 1. Which one is possible? You should observe the options. Equation of CB. Equation of CB meaning here y minus 0 is equal to 0 minus 1 by 2 minus 0 into x minus 2. So this can be understood as y is equal to minus 1 by 2 into x minus 2. Since it needs y is equal to x, substitute there. Since it meets y is equal to x, if the line y is equal to x, since it meets, so substitute here x is equal to minus 1 by 2 into x minus 2. So 2x is equal to minus x plus 2. 2x is equal to minus x plus 2. So it is becoming 3x is equal to 2 by 3. Therefore x is equal to 2 by 3. X equal to 2 by 3. Whenever y is equal to x, you can write y is equal to also 2 by 3. That implies 2 by 3 comma 2 by 3 is the given point or locus point is equal to P. You can understand whenever you are making 2 by 3 as comma 2 by 3 into 1 comma 1. It is nothing but is a complex plane. You can write this is 1 plus I. P given as it is k by 3 into 1 plus I. Therefore k value is 2. It is enough. If you calculate this one 2 0 and 0 1 we have calculated. If you calculate 1 0 and 0 2 you will not get this answer. That is why you neglect that one. This is the right answer. Now second 12th question. 12th question. If Z1 comma Z2 are nth roots of unity, which are ends of a line segment that subtends pi by 2 at origin, then n is in the form of Z1 comma Z2 are nth roots of unity, and O is origin like this. Both put here 0 comma 0. Put here this is A, this is B. At B you can put Z2. Z1 comma Z2 are nth roots of unity, which are ends of a line segment pi by 2 at origin, and n is in the form of. Given you can write Z1 whole power n is equal to 1, because whenever it is nth roots of unity, you can write this z power n equal to 1. Of course, the concept is 1 power 1 by n is nth roots of unity. But if z you are taking as 1 power 1 by n, z power n is equal to 1. Not only z1 here, z1 and z2 both are nth roots of unity. So write here z1 power n is equal to 1 and z2 power n is equal to also 1. Now by Conius theorem you can write. By Conius theorem. By Conius theorem, BO by AO. BO by AO is equal to modulus of BO by AO. Modulus of BO by AO into e power I pi by 2. One thing you should observe that if 1 omega square are cube roots of unity, then modulus of omega and modulus of omega square are the same. For every value you take nth roots of unity, modulus is always same. Therefore, this and this get cancelled. Now Z2 minus 0 by Z1 minus 0, Z2 by Z1 is equal to e power I pi by 2. E power I pi by 2 is nothing but according to Euler's formula cos pi by 2 plus I sin pi by 2. Therefore, you can write Z2 is equal to I by 1. Z2 is equal to I by 1. If you take modulus both sides, you can write like this. So write Z2 by Z1 is equal to I. Rise power m and rise power n. Rise power n both sides. That implies Z2 by Z1 whole power n is equal to I power n. That implies separately you can write as Z2 power n by Z1 power n is equal to I whole power n. Z2 power n here we decided that it is 1 and it is 1. So 1 by 1 is equal to I power 4. Directly I did I power n, of course n should be 4. Because I power 4 is 1, it is the least positive integer in IITJEE we have discussed it. I power 4 can be understood as I square whole square minus 1 whole square is equal to 1. Therefore n should be in the form. N should be given that according to options it is 4k where k belongs to positive integer. He did not give, simply he given 4k. Now 13th question. One vertex of an equilateral triangle is at origin and other two vertices are given by 2z square plus 2z plus k. One vertex formula. Before going to discuss the sum, we have if z1 comma z2 comma origin form an equilateral triangle. I think in page number 8, synopsis we have discussed the formula origin z1 comma z2 comma o z1 z2 form an equilateral triangle. Equilateral triangle, then z1 square, the property is that z1 square plus z2 square is equal to 2z1 z2. The concept is for three sides we have discussed z1 square plus z2 square plus z3 square is equal to 2 of z1 z2 plus z2 z3 plus z3 z1. If 1 is 0, among them z1 square z2 square is equal to 2 z1 z2. Already we have discussed with synopsis. Now use the formula. Given QE means quadratic equation for 13th question. One vertex of equilateral triangle is the origin and other two vertices are given. Given QE is 2z square. 2z square plus 2z plus k. 2z square plus 2z plus k is equal to 0. One vertex of equilateral triangle is at the origin, other two vertices given by. Then what is the value of k? Now, according to this quadratic equation rule, if z1 comma z2 are two roots of distinct roots of this one, z1 plus z2 is equal to sum of the roots concept minus 1, and here z1 z2 product of the roots concept is equal to k by 2. Now, squaring both sides you write here z1 plus z2 whole square. z1 plus z2 whole square is equal to 1. That implies expand like this z1 square plus z2 square x z1 square plus z2 square plus 2 into z1 z2 z1 square plus z2 square plus 2 into z1 z2 equal to 1. That implies now z1 square plus z2 square we got from formula. Directly we can write 2 z1 z2. This is 2 z1 z2 plus this is not 2 maybe just maybe z1 z2 not 2 is there. Just let us verify the formula. Maybe page number 8 formula is there. z1 square z2 is simply z1 z2 not 2. So write here z1 z2 plus 2 z1 z2. z1 z2 plus 2 z1 z2 is equal to 1. That implies 3 z1 z2 is equal to 1. So write here z1 z2 is equal to 1 by 3. 1 by 3. So that implies k by 2 is equal to 1 by 3. K by 2 is equal to 1 by 3 we got. Therefore, you can write k is equal to 2 by 3. 2 by 3 meaning 0.666. According to option, k greater than 1 by 2 you can write. K greater than 1 by 2 because 1 by 2 meaning 0.5, 0.66 is greater than 0.5. So here it is, third option. Next, 14th one. If it is given that the equation modulus of z square minus 2iz plus 2c into a plus I equal to 0. Given quadratic equation model is there, I am writing modulus of z square minus 2I into z minus 2I into z plus 2c into a plus I. 2c into a plus I equal to 0 possesses a solution for all c belongs to R. Then the number of integral values of a where it is true possesses a solution, it is only our hint. Now let z is equal to a complex number, it is in the form of x plus I. Substitute here modulus z meaning component square plus component square. So write here x square plus y square. X square plus y square minus 2I into x plus I. 2I into x plus I plus 2c into a plus I is equal to 0. That implies x square plus y square minus 2ix minus 2I square. I into I square becomes minus 1, minus of minus becomes plus 2y plus 2ca plus 2ca plus 2ci is equal to 0 plus 0 into I. That implies write like this: x square plus y square plus y square plus 2y plus 2ac x square plus y square plus 2y plus 2ac minus I you take common along with 2 minus 2I taken common x minus c is equal to 0 plus 0 into I. Therefore compare imaginary part and real part. So compare, first I am comparing imaginary parts. Comparing imaginary comma real parts both sides. That implies x minus c is equal to 0 we are getting. Therefore you can write x is equal to c. Also, by comparing real part, we can get here x square plus y square plus 2y plus 2ac. X square plus y square plus 2y plus 2ac equal to 0. Substitute instead of x, you substitute 0. That implies right here c square plus y square plus 2y plus 2ac. C square plus y square plus 2y plus 2ac is equal to 0. Let this is a quadratic equation of y. Write like this: y square plus y into 2 plus separate c square plus 2ac is equal to 0. If this QE has a solution, because he is asking possesses a solution. So solution meaning the discriminant should be greater than or equal to 0. If this has solution, of course the discriminant should be greater than or equal to 0. Now discriminant b square minus 4ac concept, 4 into 4 is like this: c square plus 2ac. C square plus 2ac greater than or equal to 0. Now divide with 4 and it becomes 1 minus c square minus 2ac greater than or equal to 0. Multiply with minus, it becomes c square plus 2ac minus 1 less than b. Here coef of x square, coef of c square comma expression, coef of c square gamma expression. The theorem we have discussed in quadratic expressions: coef of x square expression having same sign when delta less than 0 for all x belongs to R. He is discussing this possesses a solution for maybe for here also he might have given. Yeah, C belongs to R here. OF of C square comma X should have opposite sign here, not negative sign, because C square coefficient 1, it is positive, and for expression we got less than 0, so have this is opposite sign. Therefore, for all C belongs to R, delta not less than 0 input. Originally delta less than 0, it should be defined for all real numbers. But here, symbol opposite, it is absolutely wrong. So there is no solution. There is no processing of loops. That meaning, there is no solution. Meaning, for values of A, no value. No value meaning 0. 14th question, 4th option. Yes, it is 4th option. This is true for no value in right. This is true for no value of 0. No value of A, that is 0. No values. Now 15th question. Fifteenth question. If Z is a complex number having at least absolute value, having least absolute value, and modulus of Z minus 2 plus 2 equal to 1. Modulus of Z minus 2 plus 2. Modulus of Z minus 2 plus 2 is equal to 1. Z is a complex number and satisfying least positive absolute value, modulus of Z minus 2 plus 2 is equal to 1. So we can think this one. Let Z is equal to X plus I by 2. That implies you can write here X plus I by minus 2 plus 2I over modulus is equal to 1. That implies you write here X minus 2 plus I into Y plus 2. X minus 2 plus I into Y plus 2 is equal to 1. I into Y plus 2 is equal to 1. According to this modulus concept, you can apply component square plus component square. So X minus 2 whole square plus Y plus 2 whole square. Y minus of minus 2 whole square is equal to 1 square. I am writing. This is a circle. This is a circle having a center. This is a circle having a center 2 comma minus 2. Having center 2 comma minus 2 and radius. Having center 2 comma minus 2 and radius 1. Now read the question. Z is a complex number having least absolute value and modulus of Z minus 2 plus 2I is equal to 1 than Z. So the whatever the complex number we are going to find out, that complex number should associate with the circle. Now you can understand this one X comma minus 1. This is in 4th quadrant. Draw a diagram like this. 4th quadrant. This is 0 comma 0. This is 0 comma 2. I mean minus 2, negative side. This is 2 comma 0. This is the center. This is the center. So this is 2 comma minus 2. P draw like this. So what is the argument of this line? Center put C here. P be any point on the circle. This OP the distance. Let the distance is capital R. We know that is radius of circle from center to any point in radius. This is CP. Of course, it is 1. It is 1. So O means 0, 0. Now center C is equal to, we can write 2 minus 2I. So theta is equal to tan inverse of imaginary part by real part, right? Theta is equal to tan inverse of imaginary part by real part. So that is equal to tan inverse of minus 2 by 2. Tan inverse of minus 2 by 2 becomes a tan inverse of minus 1. So whenever it is tan inverse of minus 1, write here minus pi by 4 is the angle. That is why this is negative angle, negative pi. Angle meaning amount of rotation from an initial ray to terminal ray with the positive direction of x-axis. So this is minus pi by 4 with the positive direction of x-axis. This here theta is equal to minus pi by 4. Why did you write r here? To calculate the coordinates in polar form, you should apply the value of r cos theta comma r sin theta instead of x comma y. Now p is equal to, I am writing r cos theta. If small r meaning radius, if you don't get confused, otherwise change the letter capital r cos theta comma r sin theta. R cos theta comma r sin theta. Where is r? What is r here? OP is equal to r. So the distance from origin to the given point. That point should associate with the locus. That is circle. So OP is equal to r here. It can understand this is OC minus CP. That is equal to what is OC? Distance between origin and the center. Root 2 whole square plus 2 whole square. 4 plus 4. So 8. 8 you can understand 2 root 2 minus this is 1. So OP is equal to 2 root 2 minus 1. That implies now apply here. P is equal to 2 root 2 minus 1 into cos pi by 4. Cos pi by 4. Not cos pi, I mean cos of minus pi by 4, cos pi by 4. Minus I into apply here 2 root 2 minus 1 into sin pi by 4. That is equal to take common here 2 root 2 minus 1. 2 root 2 minus 1 into, you can understand this is 1 by root 2 minus I by root 2. Now see the option. According to options, you can apply 2 minus multiply this. With root we multiply 2 minus 1 by root 2. 2 minus 1 by root 2 into 1 minus I. It is first option. Yeah, option 1. Now 16th question. 16th question. If omega is a complex root of unity and ABC are the real numbers such that 1 by a plus omega given 1 by a plus omega 1 by a plus omega plus 1 by b plus omega. Logical thinking we can apply for this question. 1 by a plus omega plus 1 by b plus omega plus 1 by c plus omega. 1 by c plus omega is equal to 2 omega square. 2 omega square. Next one, 1 by a plus omega square. 1 by a plus omega square. 1 by a plus omega square plus 1 by b plus omega square plus 1 by c plus omega square is equal to 2 omega. Then we should calculate 1 by a plus 1 plus 1 by b plus 1 plus 1 by c plus 1. 1 by a plus 1 plus 1 by b plus 1 plus 1 by c plus 1 equal to dash. You can understand the shortcut. 1 by a plus omega, here omega square 1 plus omega square equal to 0. For the concept, for omega square they put 2 omega square. For omega square they put 2 omega. Now you can put simply 2. That is the logical thinking. And for calculating, we can understand omega square is equal to 1 by omega, comma omega is equal to 1 by omega square, because omega square can be understood as omega cube by omega and omega can be understood as omega cube by omega square. Now using simple formula, you can apply this one as 2 by omega. 2 by omega. Apply or understand a plus omega. Whenever omega is there, we are getting 2 by omega. And here you can apply for 2 omega square. You can understand 2 by omega square. That is why here 2 by 2. What he is asking 2 by, no, not 2 by, this is 2 by 1, not 2 students, because whatever the value is that we are substituting. Whatever the value is that we are getting. So here whatever the value 1 is, 2 by 1, 2 by 1 meaning 2. So it is second option. Now 17%. Seventeenth question, the sum of the series. The sum of the series sin alpha plus x into sin of alpha plus beta plus x square by 2 factorial x square by 2 factorial into sin of alpha plus 2 beta plus so on until infinity is dash. Large lengthy method is there, but better to put shortcut on this one. Put alpha is equal to 90 and beta is equal to 0. So many times I said that while cos terms or sin terms you are facing, then you can apply 0 degrees or 90 degrees. Put here. So it is becoming 1. Series started from here. 1 plus simply x, we leave x. Sin of alpha plus beta. So sin 90 is 1. Simply x. Plus sin of 90 plus 0, of course. So it is x square by 2 factorial. 1 plus x square by 2 factorial, like this, x2 by 3 factorial, and so on. Infinity series, the expansion, we know that it is e power x. E power x. I said all formula in first year Rolle's theorem model itself. This is the formula of e power x, Maclaurin's expansion. E power x. Now verify the option. So we should get e power x is as answer. First one, e power x into cos beta. E power x into cos beta into sin of alpha plus x sin beta. E power x into cos beta into sin of alpha plus x sin beta. Whatever the value I am thinking, apply here. Cos 0 becomes 1 into sin of alpha meaning 90, x sin beta 0. So simply it is sin 90. So it is 1. So it is simply e power x. That's all. Other than this one, no option will be satisfied. I know if you are getting any doubt, you can verify. Otherwise, you can ask me doubt. 17th question completed. Now, 18th question. Sum of the series. Sum of the series sigma r is equal to 0 to n. Sigma r is equal to 0 to n minus 1 whole power r into NCR into I power 5r plus I power 6r plus I power 7r plus I power 8r. I power 5r plus I power 6r plus I power 7r plus I power 8r. Using shortcut here, put n is equal to 1. And r is equal to 0. I mean, put r equal to 0 and you write until only 1 term. N equal to 1 means only 1 term. Sigma r is equal to 0, so write take here simply 1 term. Minus 1 power 0. This is 1c 0 into this is anything power 0, 1 plus 1 plus 1 plus 1 plus 1. That is equal to 4. 1c 0. Anything 0 formula already we have discussed in first year maybe. NC0 is equal to 1. Now 4 is there. We got 4. Fourth option. Verify fourth option. That option is 2 power n plus 2 power n plus 2 power n by 2 plus 1 here only, plus 1 into cos n prime by 4. Here you put n is equal to 1. You put n is equal to 1. So it becomes 2 square plus this is 2 power 1 by 2 into 2 into cos pi by 4. Cos 45 value 1 by root 2, 1 by root 2 and 2 power 1 by 2 becomes 8 tenths, not 2 square students, this is 2 power 1. So 2 power 1 means 2 plus 2 answer is 4. So verified fourth option. Now 19th question. Z1, Z2 be the roots of quadratic equation z square plus pz plus q is equal to 0, where pq are complex numbers. Let A and B represent Z1, Z2 in the plane angle OB equal to alpha and OA equal to OB. Draw a diagonal lines. Put here O. So this is B, this is A. Put here this is Z1. This is an angle alpha. Put here this is Z2. OA is equal to OB given. Given condition OA is equal to OB. Apply Corey theorem. Corey's theorem. According to Corey's theorem, we can write VO by AO is equal to modulus of VO by modulus of AO into e power I alpha. That implies VO meaning here Z2 by this is Z1 is equal to, whenever OA is equal to OB, given magnitudes are equal, then this will be getting cancelled, e power I alpha, e power I alpha. So Z2 by Z1. Z2 is equal to Z1 into e power I alpha. The relation is there. Put first equation. Z2 is equal to Z1 into e power I alpha. 19th question. Now Z1, Z2 with the roots of quadratic equation. And OA is equal to Z square plus PZ plus Q equal to 0, where PQ are complex number, A will represent 6. Okay. And what is happening? QE you can write. Given QE. Maybe shortcut is not possible. Given quadratic equation, Z square plus PZ plus Q is equal to 0. Z square plus PZ plus Q is equal to 0. Now for this one, if we write Z1 plus Z2 is equal to sum of what's concept minus T, and you write here Z1 into Z2 product of roots concept Q. Now apply here Z1 plus Z2, instead of Z2 you write here Z1 into e power I alpha is equal to minus P, and Z1 into e power I alpha is equal to Q. Z1 into e power I alpha is equal to Q. Now apply the Z1 value here. Z1 take common, 1 plus e power I alpha. 1 plus e power I alpha is equal to minus P. Comma, here we are getting Z1 into Z1. Instead of Z2 we have substitute here Z1 e power I alpha. So Z1 into Z1. So Z1 square you write Z1 square e power I alpha. Z1 square e power I alpha is equal to Q. Now write like this. Z1 is equal to minus P by 1 plus e power I alpha. Substitute here instead of Z1. So you can get P square by 1 plus e power I alpha whole square. P square by 1 plus e power I alpha whole square into e power I alpha is equal to Q. That implies that the Q taken this side, P square by Q you can written as P square by Q is equal to e power I alpha whole square by e power I alpha. E power I alpha whole square by e power I alpha. That implies P square by Q. P square by Q can be understood as here e power I alpha whole square by. This also we can understand as e power I alpha terminology whole square. E power I alpha by 2 whole square to get cancelled, but we are creating to get the whole square model for numerator and denominator. That implies P square by Q. P square by Q you write here 1 plus e power I alpha by e power I alpha by 2 total whole square. That implies P square by Q. P square by Q is equal to 1 by e power I alpha by 2. You understand as e power minus I alpha by 2 plus this e power I alpha by e power I alpha by 2 becomes e power I alpha by 2. Total whole square. That implies P square by Q. P square by Q is equal to, students, we know that e power I theta according to De Moivre's theorem cos theta plus I sin theta. Euler's formula. So this is cos alpha by 2 plus I sin alpha by 2. No, this is minus. Plus here cos alpha by 2 plus I sin alpha by 2. Total whole square. Here I sin alpha by 2 get cancelled. So we are getting P square by 2 is equal to 2 cos alpha by 2 whole square. Right here 4 cos square alpha. Therefore P square is equal to 4Q into cos square alpha by 2. P square is equal to 4Q into cos square alpha by 2. Option. First option. 19th question, first option. Now 20th question. Twentieth question. If Z1 comma Z2 comma so on Zn lies on the circle. Z1 comma Z2 comma so on Zn lies on the circle. Z1 comma Z2 comma so on Zn lies on the circle. Modulus of Z is equal to, then find the value of find the value of modulus of Z1 plus Z2 plus Z3 plus so on Zn minus 4 into 1 by Z1 plus total modulus of 1 by Z1 plus Z2 plus Z3 plus so on 1 by Zn over modulus. The value is equal to dash. So given, we can write here, given circle is given circle is modulus of Z is equal to 2. Given circle is modulus of Z is equal to 2. So you can write here x square plus y square equal to 4. X square plus y square equal to 4. Yeah. So center equal to 0 comma 0 and radius equal to put here 0 comma 0. This side I am substituting 2 comma 0. This side I am substituting minus 2 comma 0. Now I am thinking, just shortcut I am putting, let Z1 is equal to 2 comma root 2. No, root 2 comma root 2 square from 0. I am discussing with you. Put here this is root 2 comma root 2 plus constant. And Z2 you can think this is root 2 comma minus 2. Of course, plus minus like that. 4 ways we can think. This P, I am thinking this is Z1. 2 points and take. This is the Q. That is Z2 is equal to root 2 comma minus root 2. We know that from center to any point on the circle is called as radius. Of course, it is root 2 whole square 2 plus root 2 whole square 2 plus root 4 becomes this is 2. This is 2. It's okay. So whatever we thought it is satisfying. Now modulus of now 1 by Z1 we think. This meaning is that friends root 2 into 1 plus I. This meaning is that root 2 into 1 minus I. That meaning root 2 plus root 2I. Now 1 by Z1 is equal to completely write like this. 1 by root 2 into 1 plus I. Take n reciprocal. So multiply and divide with 1 minus I. It is becoming 1 minus I by 2 root 2 because 1 plus I into 1 minus I becomes root 2. Root of 1 square plus 1 square. In the similar way, 1 by Z2 becomes 1 by root 2 into 1 minus I. Taking reciprocal here, taking multiply with the conjugate complex numbers to numerator and denominator becomes 1 by 1 plus I by 2 root 2. Now, what is going to discuss? Modulus of, we are verifying modulus of Z1 plus Z2 minus 4 into 1 by modulus of 1 by Z1 plus 1 by Z2. So, what is the value of Z1 plus Z2? Root 2 totally you can put taking common, it is 1 plus I plus 1 minus I. Minus 4 into within the modulus. What is happening? 1 by 2 root 2 directly you can take common here. 1 by 2 root 2 taken common and within brackets you can write here 1 minus I plus 1 plus I. 1 minus I plus 1 plus I. So here minus I plus I get cancelled. Here 1 minus I plus I get cancelled. It is becoming 2 root 2 minus 4 into it is 1 by 2 root 2 into 2. Yes, this 2 will get cancelled. So this root 2 will be divided in 4 to root 2 times because 2 into 2 like this. So answer is 0. Answer is 0 here according to options. It is first option. Now let us discuss 21st question. 21st question also we applied shortcut. 21st question, if A and B are two real numbers Z1 and two real A and B are two real numbers and Z1 Z2 is non-zero complex number such that condition A comma B are two real numbers. Students observe the thing that A and B are two real numbers but not distinct. He is not mentioning that it is distinct or same or equal anything. So simply you can put A is equal to 1 and B is equal to 1. A Z1 plus A Z1 A mod Z1 equal to B mod Z2 and Z is equal to, then Z is equal to A Z1 by B Z2. A Z1 by B Z2 plus B Z2 by A Z1. Okay, let I am writing A is equal to 1, B is equal to 1, that Z1 equal to, students I am taking Z1 equal to omega comma Z2 is equal to omega square. Why? Because we know that modulus of omega and modulus of omega square are equal. Now you apply here. Of course, here you can apply, you can understand here in the concept of modulus omega equal to modulus omega square. Now Z is equal to 1 into omega. So apply here omega by omega square plus here omega square by omega. Omega by omega square becomes You can write omega by omega square becomes 1 by omega plus this is omega. Taken LCM, it becomes 1 plus omega square by this is 1 plus omega square by omega. 1 plus omega square meaning minus omega by omega. This and this get cancelled. Minus 1 we got. Therefore, whenever minus 1 we got, there is no imaginary. So this can be understood as this is purely real. This is purely real. This is purely real. So option 3. Okay, students, we have completed 21 questions. Total 27 are there. Tomorrow we can discuss these 27 questions, and I mean from 22nd to 27 in tomorrow class, and level 4 also we can discuss in tomorrow class.